So before we start talking about methods for finding the solutions to systems of equations, I want to take a minute and first talk about what they are. Right? A system of equations is just two or more equations that are combined together. Right? So in this first one here, we have two equations in two variables. Here we have three equations in three variables, and again over here, two equations in two variables. These first two examples here, these are what are called systems of linear equations, because all of the equations in them are linear. And the last one over here is a system of nonlinear equations, because at least one of the equations is nonlinear. So when we talk about the solution to a system of equations, what we mean is a set of numbers that satisfies all of the equations in the system. So if you take a look at this first one here, there's obviously infinitely many points that satisfy this equation and infinitely many points that satisfy the second one. There is only one pair of values that satisfies both of those equations. All right, those are the points, the values x equals 0, y equals 0, or we usually give these as an ordered pair, or if we have more than two variables like we do over here, we do an ordered triple, right? That's the notation that we use here. So that's one way to look at this, right? Another way to look at it is more from a geometric perspective. Another way to think about the solution is we're trying to find the place where the curves represented by the equations intersect each other. Okay, so if I were to graph these two equations here, the first one, that's y equals negative 1/2 x. So it's going to be something like this. And if we graph the second one, that's going to be, if we solve it for y equals 1/3 x. So that's going to look like this. And you can see that the two graphs cross, give or take my sketchy artistic ability. The two graphs cross here at the origin. So that's kind of the geometric interpretation. When we're doing this with nonlinear equations, if we know how to graph the equations, doing that can be really helpful in helping us to confirm that we got the right number of equations. All right, these two here, for example, are ellipses. Right, and I'm not going to be super specific, but just I'm not going to try to get a super accurate graph, but they look more or less like this, right? So when we're talking about nonlinear equations, we can have situations where there are multiple points of intersection. We'll see that more when we talk about those specifically later in the series here.